It says, what is the domain in the range of the following functions? So we don't even have to graph it. I just want to concentrate on the domain and the range. Any ideas? You can think back to the examples that we did from your homework last night. What's the domain seem to be for all of these? All real numbers. So adding 2 on the end isn't going to change all real numbers for our input. However, what does it do to our range? Yeah, y has to be greater than 2. In all the exponential functions we looked at yesterday, the x-axis was our asymptote, but when you add 2 to the end, it bumps everything, including your asymptote, up 2. So now the graph will get closer and closer to the line y equals 2, but it'll never touch it. So your y values are all going to be greater than 2. Good. Any questions on domain and range from yesterday? All right, today we're doing section 8.2. Very similar to what we did yesterday, except now we're looking at decay functions. So a very important thing to recognize is it an exponential growth or is it an exponential decay? Because that'll change the way your graph looks. Here's how you recognize one from the other. They come in the same form. It's always y equals a times b to the x. Y equals a times b to the x. The difference is if b is greater than 1, it's going to be a growth function. It's going to go up. If b is in between 0 and 1, it's going to go down. If b is negative, it doesn't fit either of these patterns. It's actually kind of a crazy graph that we don't get too much into in this class. Why do we not consider when b is 1? We're talking about greater than 1 and less than 1. We don't talk about 1, though. What would happen if you put a 1 here? Yeah, what's 1 to the first? What's 1 to the second? What's 1 to the third? What's 1 to the fourth? Okay, so that's why we don't consider when b is 1, because it doesn't change depending on your exponent. If it's anything to the first power, 1 to any power besides infinity, is just 1. So that's why we don't really consider when b is 1. It won't be an exponential growth or decay if b is 1. So we're just looking at if b is greater than 1, it's going to be like yesterday, shoot straight up. If b is less than 1, it's going to go down. Questions on this? All right, here are your first 3 examples. The only thing you're doing now is you are going to state whether the function represents a growth or a decay. We always know it's going to be something exponential, so the keywords here are growth or decay. What's my b value in number 1? 4. 4 is greater than 1. So is this a growth or a decay? Growth. Number 2, what is b?
Decay.
Yes. b is 0.75. That is obviously less than 1, so this one's going to be a decay. What about number 3? Decay, yes. b is a fraction that is less than 1, so it's also a decay. Any questions on this? All right, here's 4 and 5, same type of question. The first one, that is greater than 1, even though it's a fraction that's greater than 1. So that's a growth. Now, I want you to be careful on number 5. What is different about number 5? We have a negative exponent. Negative exponents, we talked about this yesterday, can be made into positive exponents by taking the reciprocal. We don't want to think about the negative and the exponent. So I'm going to rewrite this. I'm going to flip the 1/4, and I'm going to make the x positive. Now, is this a growth or a decay? Growth. So be careful with those negative exponents. They will trick you. What are your questions? All right, this one has the same idea as the last one. What does that negative exponent do? Yeah, you switch it to 2/5. So now it's a decay. Good, I heard somebody say it. So just be aware of those negatives they'll throw in there. Do not be fooled. All right, so now we're going to start graphing these. I told you guys yesterday we were using 5 points when we graphed them. Once you see the pattern, you don't really need all 5 points. You'll notice that it's always kind of tapers off in one direction, getting closer and closer to your asymptote. In the other one, it shoots off. Once you find that sort of general shape, you can use a lot less points. Today we're going to only use 2 points. I usually like to think of a third one as well. The book, though, on these only used 2, so I wanted to show you 2. It's kind of the bare minimum. But let's see what happens at 0, what happens at 1, and then I also like to think of what happens at -1. So if you want to add -1 on yours, you can. I'll just talk you through the -1 part out loud. So when you plug 0 in, you'd have 1/4 the 0, which is 1, and then 1 times 2, which is 2. So your y-intercept, just like yesterday, is going to be at your a value, depending on transformations. Now, when you plug 1 in, you'd get 1/4, and then 2 times 1/4 is 1/2. So you can see that this one is going to slowly go down. And then I like to think of -1 as well. -1 would cause us to flip the 1/4. It'd be 2 times 4. It'd be 8. So I know that as I'm going in the negative direction, that's where I'm going to shoot up in. Okay? So this graph actually looks like that. So yesterday we were looking at exponential growth. Something was growing very quickly. You can see this one is decaying very quickly. It's going down, 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 down. We still have that asymptote. The x-axis is an asymptote. It will never cross the x-axis. If you put your arrow down here, I will take points off. So just make sure you're getting closer and closer and closer without touching it. So bare minimum is 2 points here, just to notice the shape. Once you notice that it's a decay, just like we did 1 through 6, that'll kind of help you determine your shape as well. But pretty simple on these once you kind of notice the pattern. Any questions?
So it never goes over the x-axis?
Depending on your graph transformation. Like if we would have put a -1 on the end, then it would never touch the -1. So your asymptote, depending on transformations, can switch, but in general, it's the x-axis on these. All right, here's number 7. 8. Gotcha. Quick things to notice as you're writing this down. The a value here is negative, so that's going to put all of our y values negative. That's why you can see mine just focuses on the bottom half of the coordinate plane. Again, I'm just going to focus on 0 and 1 just to get the general shape. I also, like I said, like to think of -1 just so I can sort of get a little bit more of the picture of when the drastic change happens. But when you plug 0 in, of course, that would give you your y-intercept. We know the y-intercept is the a value. So I have a point at -3. When you plug 1 in, you'd get 1/2 times -3. So you'd have -3/2. Of course, that's -1.5, so when I graph, I'll go between the 1 and the 2. Again, our x-axis is going to be our asymptote, so as you're going to the right, don't hit the x-axis. If you want to think about how quickly to shoot off to the left, you can think of what would happen if you plug a -1 in. That would cause the 1/2 to flip. So now you have -3 times 2, so you'd have -6. So you're going to shoot all the way down to -6. Again, if you don't want to actually graph that point, just sort of aim for it. That should help you out. Questions? Positive A values mean all your Y values, depending on transformation, should be positive. It's also going to be our Y-intercept, so I know when I plug a 0 in, I'll be getting a 4. When you plug a 1 in, you'll have 3/4 times 4, which is just 3. So it's not a super drastic decay, but it will still continue to go down until your asymptote, which in this case is still just the x-axis. We didn't add or subtract anything on the end. If you want to see what happens to the left, just to get an idea, if we plug -1 in, we would take the reciprocal. That would be 16/3. 16/3 is 5 1/3, so it'll be going up, but not super drastically either. So a little higher than the 5. So this one's not a super drastic decay, but it is still going down towards the x-axis, never touching it, and it's going up as you're going to the left. Questions? Here's number 10. I think we do have 12 examples today, so just a couple extra. Those first 6 were super easy. So got to give you a little more of the tough ones. Again, B value is less than 1, so it's going to be a decay. A is -5, so I know that that's going to be my y-intercept. It also puts me in the negative y values for my whole graph. So when you plug 0 in, you get that A value of -5. When you plug 1 in, you get -5 times 2 on the top. That's -10/3. Just multiplying fractions there. That is like -3 1/3, so a little below the -3. If you want to see what's happening to the left, you could plug -1 in. That would cause you to take the reciprocal. That would be 15/2, which is like -7.5, so it's going down in the negative. In the right, it is going towards that x-axis, not quite touching it. If you feel like this is not enough information, you can go ahead and plug 2 in, and 3 and 4, and see exactly when you get into these little fractions. But really, these 2 points are enough for me. Again, these are just sort of quick sketches. Questions on these? All right, let's look at one that has a little bit of a transformation in there. Now, I'm going to actually show you how I do these when I'm working through them. I showed you on one of your homework problems. It's a little differently than the way the book presents it, so I'll take you through the animations of what the book says after I show you my own personal way. When I do it, I just make an XY chart without the transformation first. And again, I'll use 3 points around the origin just to give you a little extra information. So when you plug -1 in here, you would get 4 because you would flip the 1/2 and multiply. When you plug 0 in, you would get 2. When you plug 1 in, you would get 1. So before the transformation, before the +3 in the exponent, this is what your graph would look like. Everybody agree? Now, that's not actually what I want to graph, though, right? Because I have this +3. What does the +3 in the exponent cause your graph to do? Left 3. Mathematically speaking, XY chart, how do you go left 3? You subtract 3 from the x's. So I think it's easier to do it from a table. The book recommends graphing them both. I think the table is a lot easier. So I'm going to just take 3 away from each of my x values. That's going to cause the whole graph to shift left 3 spaces. So this would put me at -4, 4, -3, 2, and -2, 1. And then I would go through and graph those 3 points. So that's my personal method. Here's the way the book recommends you do it. They actually go through the graph instead of just the table here. So it's still the same sort of points we found. Again, they don't do the -1, but I like to. So they start with the graph, and then they shift the whole graph left 3 spaces. Again, easy with technology, not so easy paper and pencil, so I like to concentrate on the table. But you should end up with this same graph. Everybody at that point? All right. Anytime we do transformations, we like to focus on the domain and range and any changes it might have caused. Did it change our domain? No. You can still plug in any number. Did it change our range? Well, our range is not all real numbers, but it wasn't before the transformation either. What is our range? Yeah, it's still just greater than 0. It was before we moved it left 3. It still is. Questions? So go ahead and work through those problems. It's only the odds. If you need more graph paper, there's some up in front. Let me know if you have questions. We'll start just like we did today with questions over the homework at the beginning of class tomorrow, and then we'll move on to 8.3.